hyperbola.
Oh, that's what I was gonna say. A hyperbola. I love a good.
Hyperbola is
Yes.
actually the way you pronounce it,
Yeah.
but I mean, it's a fun one to mispronounce.
Hyperbola.
It's not a hyperbole either.
No, that's like
So-
one of them English things.
Yeah,
where
something like that.
You're on highlighter.
Yeah, I am.
All right.
Woo-hoo. Okay, so BT dubs on our note pack, our graphic organizer. It didn't print, so make sure you copy down what's going on here on this table.
And also BT dubs, this is super similar to the ellipses that we've been talking about.
Oh, absolutely.
Yeah.
The key difference is there's a minus sign instead of a plus sign.
Right. Now, order here is important, and we talked with ellipses that you could have, it didn't matter if you had X first or Y first, but since there's the minus sign now, it really is important.
It's so important. And here's what it changes. An X squared first is this graph that we've got on top here where your curve, which is the only part of this that's actually the hyperbola, is the curves on the sides.
Right.
We're just going to use, we're just going to use the rest of it to draw it. So if it's X squared first, it's on the left and the right side. If it's Y squared first, it's like this bottom graph where it's on the top and the bottom.
Right.
So it's super important.
So it kind of opens the direction of whatever's first is the easiest way to remember that.
Right, and notice that in both cases, A is the one that's first, B is the one that's second, and that's going to matter whenever we fill in our foci and our vertices, and then now we've got these new words. The transverse axis is the one that's between the vertices. So like on this top graph, the vertices are like, if you imagine that these kind of look like parabolas, the vertices are like the vertex of the parabola.
Like the vertex, yeah.
They don't actually behave exactly like a parabola, but they're U-shaped. So
Yeah.
so that's our vertices, and our foci are
They're actually going to be
in
the
here,
point,
right?
yes, the point that the graph curves around, just like with a parabola. So again, we've got this situation where the hyperbola is bent around a focus.
Yes. And this time what's going on is that each of these points ends up being a constant difference, whereas in
Right.
ellipse it was a constant sum, but
Right.
this is going to be a constant difference. And so the transverse axis is the axis that goes between the vertices. So this direction would be the transverse
Right.
axis. The conjugate axis, which would be the opposite one, would be the one that goes the other direction.
Now, here's an interesting thing that you need to remember with a hyperbola is that with an ellipse, we knew that our major axis was always the longer, the bigger number.
And that's not necessarily
That's not
true
necessarily true.
Because here, our transverse axis would be this one, and I believe that's the shorter
Looks
axis
shorter,
here.
right.
Because it's only 4,
Right.
and this one is 6. So, and then we do have asymptotes. That's what this X is asymptotes, and we can find the equations for those asymptotes. Our Pythagorean relation that helps us find C is the normal Pythagorean theorem for hyperbolas.
That's how it works for this
So
guy.
make sure you're paying attention because it's not on ellipses, but it is on hyperbolas.
Right.
You want to do an example?
Yeah, sure. You know, one cool thing about hyperbolas is, everything kind of bounces back towards that focus, I believe. Isn't that correct with the hyperbola?
You're talking about in like real world stuff?
Yeah, in real world stuff.
Well, I know it does that for a parabola.
Yeah, I think it
so
does too for a hyperbola.
I guess we'll have to find out.
Well, if you've got the old Dish Network satellite, this is some of the theory that allows the Dish Network. It's the hyperbolas and ellipses.
And parabolas.
I'm sorry, hyperbolas and parabolas, which allow those TV
It
signals
helps
to
them figure
receive.
out where to put the
The
receiver
inside,
to work
the
it best.
little-
It's actually at the focus of
Yeah,
the
the
parabola.
antenna point, right, the little thing that sticks up. Well, you can really have a lot of fun with your friends that have Dish by taking tinfoil and putting shiny side out around the
And the antenna
around
thing?
the antenna thing
Because
because
then it just reflects
then
back
it
and forth.
reflects it back into space.
That sounds like a terrible prank to pull on
Yeah.
somebody. Don't
So-
do this at home, kids.
And if you do, don't say where you got it from.
Example 1. Let's find the vertices and the vertices and the foci of the hyperbola. 4x squared minus 9y squared equals 36.
So we got to make it equal 1.
Yes, we do, because that's standard form. So I should divide everything by 36 in order to make that happen.
That's correct.
So that gives me x squared over 9 minus y squared over 4
Right.
equals 1. So the vertices, man, we don't have a chart in front of us. You want to go get like your book or something?
Yeah, I got it. I got it right here.
I will say that underneath the first thing, is a squared, so that means a is
We're going to
3.
actually start at 0. We're going to start at 0, 0. That's the center.
Right, the center of our hyperbola is at 0, 0 because there's no parentheses for x and y.
And a is going to be the square root of 9.
And b is the square root of 4, which is 2. And so our vertices...
You're going to move left or right.
Yeah.
So we're going to move left 3 and right 3 from the center to get our vertices.
So that should be plus or minus 3, comma 0.
Yep. That's it.
If x is first?
No, that's right.
Yeah, okay. Not like I'm doubting you or anything. So our foci...
Well, I feel like you are, but that's okay.
Okay. Our foci, we need to figure out what c is.
So a squared plus b squared.
Yeah, a squared plus
So
b.
square root of 13. Your writing today is terrible. What's going on?
I don't know. So that's 9 plus 4,
13.
Which is 13. And so we square root.
You may
So
just need to give up while you're ahead.
C is the square root of 13.
And remember, it's actually technically plus or minus the square root of 13.
And that ends up coming into
And that's where that
effect
shows
in
up,
our
right.
formula. So there's our vertices and our foci.
Right.
All right, next, find an equation of the hyperbola with foci 0, negative 3, and 0, positive 3, whose conjugate axis has length 4.
That's b. That's going to be the b part, half of that.
So half of this is equal to b. So b is 2. Sketch the hyperbola and its asymptotes to support your sketch with a grapher. Now, they're going to give us all kinds of different information like they did with parabolas and ellipses, where you got to sit and sift through and figure out what is actually happening. Right. So for one thing, since it's a plus or minus situation, we know the center of this hyperbola is at 0, 0.
Right, because you're going the exact same distance both directions.
Right, and since the y changes, that is a situation where y squared is first.
Right.
We said that b is 2 because of the conjugate axis.
So that's got to go under the x. So that would be 4 under the x.
Okay.
2 squared.
Yeah, sorry, 2 squared, which is 4. And so now we're just stuck having to figure out what a is, but we know that c is
3, yeah.
Because
so
that's
c
a
is
part
3.
of the foci.
If b is 2, we can use our Pythagorean theorem then to figure out what a squared is. And remember, we don't have to square root this. So if we get some like really weird number like 17, we don't have to square root that. We just leave it as 17.
9 minus 4 is 5. What we want under here is a squared.
Yeah,
So we just put
there you go.
5 in
Bam.
there. Now, I think hyperbolas are kind of fun to draw.
They are fun to draw.
They're kind of intricate in some ways. Here, let's do this. All right, so it's centered at 0, 0. And what we do is we go up and down, because underneath y, we're going to go up and down square root of 5. We're going to go left and right 2, and we're going to make a box.
Hold on one second. You do that, and I'm going to do this real quick.
Okay, so up and down, I guess a little bit more than 2. Let me switch colors. Left and right 2. Well, that's not a perfect box by any means, but you know, things happen. All right, so once you have your box drawn, then it's time to draw your asymptotes. So they make an X through the center and through the corners.
Sorry about that. I had to handle that situation right away.
All right, and then you look at what's first here. Y squared is first, so our
we're
graph
going
is
up
at
and
the
down.
top and the bottom.
Right.
And it looks like U-shaped graphs. They
Right.
go towards the asymptotes, but they don't cross them because that's what asymptotes are.
Right. They're like little boundaries.
Yeah. So that's our hyperbola.
There
and
you
then
go.
if we were supporting with our grapher, we would need to, if we have an 83 or 84, you'd have to add x squared over 4 to the right side. You'd have to multiply by 5 and then
take
end
the
up square rooting.
And don't forget, you're going to do plus or minus on that.
Right. So.
And it graphs it a little bit strangely when you do this too, by the way. But if you've got the Inspire, if you've got the latest version of the operating system,
Which is key.
Which is key, as we've discovered today.
Yes.
Then you can just graph your hyperbola right away, which is also really nice.
Yes. So this is what you should get if you solve this for y, and then you would put that into 2 different y equals, and it should give you something. And sometimes they can look kind of funny. It sometimes will actually show either one or both asymptote because of the way the calculator works.
Right.
So.
All right, good talk.